turn on the video, please? Dr. Noor.
Hi. Good afternoon.
First, before I would like to proceed with my presentation. And then after that, if you want to close your video, we can proceed. After this. Hello. Where are you from? How, Miss How? Maiden How?
I'm from UPM also, new lecturer.
Okay. Okay, new lecturer. Dr. How?
Yeah.
From what faculty?
FVP from JPST.
Okay. Nice meeting you in person.
Yeah.
Okay, so only 19, 20, then I can like, we can proceed with the activities today. Alright? Before I would like to start my presentation, I would like a bit introduce myself. Okay, I'm from Jabatan Pengajian Sukan or Sports Studies. Therefore, before we start, because this is noon time, I would like to have a bit of aerobic activity. Are y'all okay?
Yeah.
Alright? Okay, hang on eh. You just need to follow this video. Right? Hang on.
Hello, doctor. Good afternoon.
Yes.
Sorry, I just setting my video because my laptop setting is already automatic off, so I need to find back to on my video.
No worry. Go ahead. How to share this though? Hang on there. Okay. Right. Let us do some aerobic, yeah? Do you see the video right now?
Yeah. Yes.
Alright. Just a minute.
Mr. Ragaman, are you home? Who is Mr. Ragaman? Mr. Ragaman, I brought my sister with me. Can you tell us a story, please?
Come. Just move a bit.
Oh my God, petang labu nak cendol pula biar peti. Nasib kau baik, mood aku baik. Oh, bulan puasa baru nak mulai.
Come on, Dr. How.
Tak langsir macam nadaya. Ragang lalu hanya aku yang tahu. Oh sayang, hanya kita berdua kekal sampai tua. Oh bagaimana dengan kita tersenyum tambah. Oh, hanya kita berdua kekal bahagia. Walau bila dibuatnya, aku sayang padanya. Tak berkali-kali kau buat lagi. Tolong. Tak berkali-kali kau buat lagi. Tolong. We go. Makan malam sudah dihidang. Kau masih melarang. Tak tengok bola. Kau ajak keluar. Ya Allah. Mesin kereta baru kedua.
Zakwan, follow this.
Nasiblah baik muka kau cantik. Bulan puasa baru nak mula. macam naraya, ragamanmu hanya aku yang tahu. Hanya kita berdua, kekal sampai tua. Oh, bagai bulan di bagian bintang.
Alright. Okay, that's enough. We are going to our main business today. Alright. First of all, when you are learning statistics, everything's like, you guys definitely like thinking about all these formula, equation, all this ANOVA, MANOVA, modeling stuff, right? Am I right? That's how. Okay. When I learned my statistics before, I learned it in a very holistic, it's like abstract way. Okay. Because for me, statistics, when you involve maths, it's totally, especially for those Americans, when I was there, is a bit overwhelming process for them. Okay. To calculate, and I don't really get used with the system over here. Everything's about maths, everything about equation, putting all the numbers. But then I have to give credit to my maestro in statistics, whereby I will introduce him after this in my slide. So a bit about myself. I graduated my bachelor degree at University Malaya in exercise physiology, and I completed my master's at Western Michigan University in physical education pedagogy, and I pursued my PhD at Texas A&M University, and then graduated my PhD over there. So a bit briefly about myself, I taught at Texas A&M for 3 years before. Those are all the photos with my students. I taught over there physical education, physical activity, statistics, research method, and teaching approaches in physical education. So literally, I found it's really amazing experience. Then I miss them, especially all those mentors. So statistics, okay. Okay, this is my maestro, my idol. He was my professor at Texas A&M University, used to be distinguished professor, Bruce Thompson, where I took a lot of classes in statistics with him. A maestro whereby Jacob Cohen, if you familiarize in statistics, this prominent scholar, he cited his work before, Jacob Cohen, Thompson's work. So Thompson's, Prof. Thompson's, or Dr. Thompson, he's a guy that, you know what, introduced me, taught me the statistic is not difficult. Okay, as long you understand the concept, because literally our field as a social scientist or educational researchers, we are just merely end user of the testing. Okay, all this MANOVA, ANCOVA, in experimental, in terms of modeling, structure equation modeling, literally we are end user of it. Okay, nothing much. Okay, so he's the one that literally introduced me. Okay, if you, I can share to you his book later on. Perhaps you can email me. His book, statistics, his statistics book, literally is like reading a novel. It's really amazing book, because literally it's like, okay, I'm learning statistics, but then literally it's like I'm reading a novel. His example is very simple. His exam question, he used just a very simple maths equation. Obviously, you need to know all these mean differences, yada 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 stuff. However, when you know the principle of statistics, null hypothesis testing, then you will understand. Oh, it's just like it's ingrained. It will stick in your brain. So, literally, the topic today is, it relates to Jacob Cohen's article. The world is around P less than 0.5. But then I modified the title of Jacob Cohen to why the world is still around P less 0.05. For a student, for students at FPP literally, or perhaps from other faculty, or the lecturers from other faculties right now, we are like flabbergasted normally. It's like, oh, my result, is this a normal question for you guys? Like, oh, my result is insignificant. Okay, am I right? It's insignificant. For us, for Thompson's, it's okay. It's insignificant. That's why it's called research, exploring, discovering, okay, replicating someone's experimental design, replicate, okay. So the world around us right now, I mean, it's like literally in the state. What can I share over there? They don't care about all these what I call sheets of P less than 0.5. What they do care, how meaningful the research to the community, to the society. So, and when I came back, I literally observed, especially for the FYP student, oh, my result is insignificant, doctor. Should I like tailor the data? For me, I've been like trained a research unit to have an integrity. Okay, so if it's insignificant, it's insignificant. Just report it. Nothing much. I mean, it's like nothing to worry about. You do not need to feel flabbergasted about insignificant result. So, have you experienced? Oh, my result 0.05. Yay! I'm in a good shape of research. Do you experience it, guys? Right, Dr. Norin? Yay! That's the first words that, oh, significant. Oh, it's a good thing. However, it's like it's a useless and worthless for you. It's like, oh, you are getting significant value in your research. Yeah, it's good. It shows something, but then it's nothing like what I love this comic image. It's like P less than 0.5 is a tale told by an idiot. Okay, because based on Smith and Hunter, it's a retard practice, and nothing can be like meaningful in terms of body of knowledge, especially in our research. Okay, because why? Later on I will explain. This is like, you know, P05 is like the field of eureka, literally. Yay! That's normally what our students, our researchers, lecturer feel like, oh, my result is significant. So I would like to ask you guys. Probably you can like put your answer on the chat box. Is it significant or statistically significant? Is it significant? You can type. I'm waiting for the answer, guys. Significant. Okay. Thank you, Catherine. Statistic significant. Okay. Statistic significant. Okay. Good. Thank you, Dr. Norin. Anybody can answer? Stats. Okay. Thank you, Dr. Hao. Should I call Dr. Shuping or Dr. Hao?
It's okay, both. Shuping is my
Can I
name.
call you Dr.
Yeah.
Shuping? Oh, yeah, I know.
How is my surname?
Dr. Hao is your family name.
Either one is okay.
Yeah. Okay, okay. Okay. All right. The answer is statistically significant. Why statistically significant? So, it's a categorization of decision to reject as statistically significant, not statistically significant is one of the damaging language literally in our research. Okay, and most of the students and perhaps a seasoned researcher though, sometimes they just say significant, because significant is a statistically significant because what you determine your p-values, all these things through an equation. Therefore, it is called statistically significant. That's why it's called statistically significant. And when you got a p-value, significant value the result, nothing much. Like I say just now, it's nothing much that you can like, describing, oh, it's a meaningful. So always say statistically significant, especially for those undergraduate student, because you are not familiar with this term. But then always say statistically significant. It's not, oh, my result is significant. It's literally is very, when you use significant in daily life, it means meaningful. Okay, it's difference. But then when you use statistically significant, is a noun, both a noun, then it shows that it is based on the computerized notation, equation calculation. Okay. So activity question, you can put your answer. What is P critical, alpha values, P calculated, and have you heard anything about null hypothesis statistical testing? For these doctors, definitely they know critical alpha values. You can type your answer in the chat box. What is pre-critical? Perhaps, in 3 words, what is pre-critical alpha values? P calculated, null hypothesis statistical testing. Any answers? Catherine? Linda? Ellie? Engku Mardia? Any answer? Y'all can answer it. There's nothing wrong. Okay. That's a normal answer that I see. 0.05, 0.01. That's what you know. That's very mundane. It's a very standardized answer. Okay. Normal. Okay. Good job, Muhammad. Mean significant, okay. Any other answers? Rejecting null hypothesis when it's true. Okay. Good job, Dr. Nana. Excellent. By the way, Dr. Nana is from my Department of Sports Study, Dr. Rosanna, Azisha, perhaps you can answer? Gilta? Helmi Asri? Koliv, you are here. You might want to answer it. Oh, Dr. Mota is here too. Welcome, Dr. Mota. Okay, alpha is a significant level. Okay, excellent, Dr. Nori. Okay, I would like to proceed, okay? So, literally, obtaining statistical significant result does not show any important thing, okay? It's merely a mathematical an equation. Literally what test you use during your hypothetical testing, whether you want to compare the means, whether you want to predict, whether you want to determine the differences between 3 groups. Perhaps you want to do multivariate, you have more than 2 dependent variables. So it's just based on your equation, statistical and significant, okay? And non-significant result, perhaps like alpha values P calculated, it depends on what your hypothesis. Obviously, if you want to conduct a cancer study, side effect of cancer study, definitely you don't want a statistical significant. Okay, it depends on purpose of your study, your hypothesis. So, whether it's a single tail, one tail, so that's that kind. If you are looking for like high performance, definitely you want to like modify, improvise your statistical testing. So that's what I mean. Non-significant, it doesn't mean it's not good, and it depends on what type of research you want to use. You are conducting your hypothesis. So now hypothesis testing. So okay, type 1 error. Where this is I would like to ask you. You can answer it on text box. Just now some of you guys saying 0.05, 0.01, perhaps 0.1. When do you decide the alpha values normally in your research? Normally you can like answer it in your text box. When do you decide your alpha values normally? Any answers?
Hypothesis.
During hypothesis. Good job. Okay. You can text on text box too. At least I can
Oh,
read.
sorry.
It's okay, doctor. Doctor, no worries, no worries. You can answer it, or perhaps you can type it in the text box, in the chatting box. During hypothesis, yeah, you are right. Any? I would like to throw a question to you guys, especially for those graduate, because all those lecturers, they know all this principle. Those postgraduate students, when do you decide the alpha values? Zul? Yukai Ho? Any answers during hypothesis? Okay. Hazriani? Catherine? When do you still remember during your FYP time? You still remember? Okay, literally you are this. I mean, normally you decide your alpha values literally before you start any statistical testing. Okay, in a research, for those in postgraduate, for information, normally you select your alpha values before you. I mean, once you have data, then you want to test your hypothesis, then you will decide your alpha value. Can I set my alpha value perhaps 0.03? That's my question. Can we decide your alpha values at 0.04? Can you decide your alpha values at perhaps 0.7? Because okay, alpha values is literally, this is I would like to share my experience when I select my alpha value. Bruce Thompson brought his nephew, aged 8 years old, and then asked his nephew to throw a coin. That's why I put a coin. This is a quarter of a coin, and then he just wanted to show that alpha value his niece at 5 years old can determine. Okay. You do not need specifically decide it should be 0.05. It should be 0.01. Okay. However, the alpha value, it depends on the researcher's decision. Okay. That's what I would like to share, because alpha values literally, even for a niece 5 years old, Dr. Thompson's niece can decide, and it shows how really subjective it is when you are deciding alpha values. Just because in the research, especially in our research in faculty education research, the other research setting 0.05 doesn't mean we cannot decide it as 0.03. Doesn't mean we cannot decide it at 0.1. Okay, because on APA format, you literally is like you can whether set or reporting is equal. What is your p value? okay, on APA format. It's not necessary for you to report less than 0.05. So what I try to convey is, you can set at any alpha values, but then how confident you are in your sampling distribution, okay, about your intervention. This is applicable especially for experimental design study, okay. For research in survey, we can have another further talk about that discussion. So literally type 1 error when happens, this is very not technical, try to make it simplified. Type 1 error happens when a researcher literally choose a wrong alpha values. That's the thing. What happened to the alpha type 1 error normally? Okay. Yeah, type 2, yeah, definitely. It's related to your sampling distribution, the power of sample size, everything. Okay. Type 1 error is literally a very subjective error that a researcher normally does. Okay. Type 2 error, it is related to your technique, I mean, it's like statistical power. So this is how do you select? You literally you can select. Are you familiar with this table, guys? For those postgraduate, Arfina, Arfina,
Yes.
are you familiar with this sampling distribution?
Yes, doctor.
Okay, all right. So this is what we call null hypothesis statistical testing. This is has been refuted by Jacob Cohen about null hypothesis statistical testing. So I will carry on with my presentation. So this is NHSST contingency table. When you reject your hypothesis, yay! Something's going on in my research. Okay, but can you think if you select a wrong p-value? That's my question to you guys. Okay, this is for me. This is important table for you to understand type 1 error and type 2 error. Okay, pre-critical, fail to reject. When you reject, what will be the next consequences? Fail to reject, what is the next ramification? So in principle, the NHSST principle contingency table, literally, if you cannot, I mean, literally the words is that you cannot make both type 1 or type 2 error and type 2 error on a given any hypothesis testing. You get what I mean? If, okay, if you reject your hypothesis, you could not have made a type 2 error. And type 2 error is irrelevant. This is principles. Okay. Once you fail to reject, you could not have made a type 1 error. And type 1 error is irrelevant. So it cannot, I mean, both type of errors cannot be cannot be occurred at the same time, whether it's type 1 error or type 2 error. So that's my message in this slide. So I would like to proceed with this. This is why I say this is literally how Thompson's try to describe how difficult, I mean, how dangerous it is when you are misinterpreted about your p-values. Hang on, yeah. Where is this? I need to show a video. Hang on. Do you see a YouTube video right now, guys? Dr. Mary, do you see it?
No, doctor.
No, doctor. No.
No? Okay, hang on. Okay, do you see it right now?
Psychology and many other disciplines rely on the p-value to interpret data. But can we trust the p? You might think of p as the effect. Lower the p, stronger the evidence. Is the strength of evidence. There's an effect. Lower the p, stronger the evidence.
I need to play back from start.
Psychology and many other disciplines rely on the p-value to interpret data. But can we trust p? You might think of p as the strength of evidence. There's an effect. Lower the p, stronger the evidence. There's language to talk about p-values. Less than 0.05, significant. Between 0.05 and 1.0, approaching significance or running away from it. This language suggests truth. 3 stars, an effect exists. Greater than 1.0, it doesn't. Think how you feel. 3 stars, yay. Between 0.05 and 1.0, frustration, so close. And P really matters. 3 stars, fame. Greater than 0.05, a waste of effort. Maybe no PhD. So the p-value determines what we believe and what gets published. Does it deserve so much faith? If p reveals truth, a replication should reveal the same truth, so give roughly the same p. Or we could ask, is p a reliable measure of strength of evidence? If so, repeating the experiment should give about the same p. Our basic question, if you repeat an experiment, how much will p vary? If p deserves our trust, the answer needs to be not too much. Let's mark the moods of p-values. 3 stars, jump for joy, bright red trumpet. 2 stars, upbeat clarinet. 1 star, okay. Between 0.05 and 1.0, question mark, a bit blue, trombone. Greater than 1.0, blue depression, deep trombone. Now the simulation, to see how P varies as we repeat an experiment. Suppose your pep-up therapy increases well-being scores by 10 on average. Here's the control population mean 50 and the experimental population mean 60. Each is normally distributed, standard deviation 20. Population effect size is 10, that's half a standard deviation. So standardized effect size delta equals 0.5, a medium size effect. Our control and experimental groups each have n equals 32. Run one experiment. The blue dots mark the scores for 32 control participants. Here's their mean and 95% confidence interval. Here are scores of 32 pep-up participants and their mean and confidence interval. We focus on the difference, so here's a difference axis, 0 lined up with a control sample mean. The green dot marks the sample difference, and here's the confidence interval on that difference. This experiment estimates the effect of pep-up to be about 15. Another experiment, the first result drops down, and the second estimates the effect to be just a little more than 15. Run repeated experiments. This dotted line marks 10, the true effect of pep-up. These intervals bounce around, and in the long run, about 95% will capture the true value. Just the occasional one, such as here, will just miss. Now, p-values. Run an experiment. Here's its two-tailed p-value. The confidence interval does not include 0, so p is less than 0.05. Another experiment, the interval does include 0, p is greater than 0.05. Run many experiments and look at these p-values. They're anywhere from 3 stars to 0.48, 0.58. It seems you can get just about any p-value. We'll collect a lot of p-values into a frequency histogram to study how p varies with replication. The latest experiment gives 1 star, marked by this highlighted square in the 1 star column and this small figure. Here's the distribution of p-values. They vary across the full range from 3 stars to greater than 10. The statistical power is 0.52, meaning in the long run, 52% of experiments give p less than 0.05. So the 1, 2 and 3 star columns will total 52%, as they pretty much do. You might suspect trickery. Have I chosen some weird extreme case? Absolutely not. 2 groups of 32 is quite large for psychology. 0.5, a solid medium-size effect. Also, studies have found that in many areas of psychology, the median power of published research to find a medium-size effect is about 0.5. My simulation is typical for much of psychology. Doing a typical experiment amounts to closing your eyes and choosing a random interval from those on screen, a random p-value from the column here. It's p-value roulette, and the histogram gives the probabilities of the different outcomes of a spin of the p-roulette wheel. Let's visit the p-value casino. Say when you want to stop and see what result your experiment gives. Oh dear. Oh dear. 2 stars. Getting 2 or 3 stars may be more a matter of luck than skill. Here's another way to illustrate how p varies for our typical experiment, the dance of the p-values. The conclusion has to be that p is a highly unreliable measure. Whatever the p you obtained, it could easily have been very different just by chance. For a typical experiment, p tells you virtually nothing. You simply can't trust p. Here's the histogram for power 0.52. Change the population effect size delta and see separation between the distributions, power, and histogram all changing. This ESCI simulation lets you play around with features of your experiment and see how the distribution of p changes. In just about every realistic case, p-values show dramatic variability. With effect size 0.5, vary the sample size and see power and the distribution of p changing. With n equals 62, large samples, power is 0.8, often considered acceptable power. The dance of the p-values gives more trumpet, but still p-values jumping all over the place. Would you like your tenure dependent on winning this version of p-roulette? Back to our typical experiment. Of course, a real-life researcher doesn't know about the populations or the true size of the effect, and has only a single experiment. But now, in your mind's eye, you know about the infinite sequence of experiments. Which gives a better idea of the infinite set, your interval or p-value? I suggest knowing one interval does tell you about the whole infinite set. Its width gives some idea of how much the means bounce around with replication. In dramatic contrast, a single p-value tells you virtually nothing about the whole set. It's simply one value chosen randomly from the histogram, which has enormously wide spread. A confidence interval is much more informative than a mere p-value. Medicine adopted confidence intervals more than 20 years ago, and meta-analysis to combine evidence over studies. We shouldn't let p control our research decision-making. It's simply not reliable. You just can't trust p. Here's psychology struggling out of the p swamp into the promising garden of confidence intervals.
Now, y'all understand? Guys? No, yeah, it's okay, Linda. It's okay because this is It's going to be, I mean, this is your first semester. Later on, once you are done with your statistic class or method class, then you understand what's the dancing p-value. Okay, for those lecturers, I believe they totally understand about this. Okay, what is the p-value, everything. So I would like to proceed with my PowerPoint. Right. So right now you totally understand why, like, you know what we call this in this is like, you know what, when we become a really depending on the idolizing the p-value, that's what happened, the danger of p-values. Okay, so therefore what's way forwards, instead of you are just relying on p-value, perhaps you guys like, oh, my result is insignificant. Points to be taken from this video which is like this: a lower value sometimes interpreted as a meaning there is stronger relationship. This is misconception. Okay, I literally refute this statement. However, statistical significance just showing the probability or chance that your statistical significance will false, your inference will false within the 5% value. That's the only thing about the p-value. Therefore, a significant p-value tells us something that your intervention in your experimental research could work, probably work. However, you don't know how is it, how effective is it, how effective is it, your treatment in your experimental research design. And it can be argued the size of effect promotes a more scientific approach. Effect size, unlike significant tests, effect size is independent of sample size, whereby what I do really emphasize when reporting any statistical findings is to put effect size and confidence interval. This is what literally Jacob Cohen's article 1994 is a really old article, but then Jacob Cohen has emphasized about effect size and confidence limit or confidence interval. So please don't expect is a magic cure when you are doing any research in experiment or survey. Perhaps don't expect for a magic on in null hypothesis statistical testing. Cautiously interpreting your result. Okay, cautiously. Once it's significant, while you need to go into your data, okay, make sure there's nothing wrong with your analysis, with your research design, with your sampling process, everything. The third point to be taken from Cohen's articles, reporting the effect size. He reiterates I believe the third time in his article, reporting your effect size a form of confidence limit. So solutions. This is what I try to emphasize in, the gist of this presentation, the academic discourse for today's effect sizes is a measure of the magnitude of experimental effect. Whether it's experimental or survey, you need to report an effect size. There are a lot, probably I will share to you guys in next workshop, what is clinical effect size, what is practical effect size, what is just a research effect size, the type of effect size. So there are three types of effect size in terms of meaningful, how to interpret the effect size. But then there are three types of effect size. Standardized means different. If you guys familiar, Cohen delta, glass D, everything. Okay, odd ratio, and then correlation coefficient, whether it's a Pearson or Spearman rule. So that's kind of effect size that you need to report when you are writing your research design. And please report your confidence interval too, just to justify your finding, whether it's insignificant or non-significant. Just report your effect size. So what did APA Task Force Committee statements in 2001? A failure to report effect size is literally a defect in your research design and reporting your research. This is their statement. One of the committee member was Dr. Bruce Thompson. So he emphasized that please report effect size because it indicates, if you don't report, indicates a flaws of research design. It's very big words, okay, strong words that the task committee use. So thank you all, very short and sweet, because I believe if I would like to share about what is effect size, is going to be like 2 semesters class, you know, the effect size. So that's a very snapshot to expose you guys, to introduce you guys the basic principle, what is null hypothesis testing, what is effect size, why is it you cannot rely on p-value, why is it jumping around if you replicate an experiment, a research from someone, research design. That's how the gist of this study. So Q&A, if you have any question, I can entertain 2 or 3 questions, because after this I will have a class. But then if you need further clarification, you can email me at juzaily@upm.edu.my, or perhaps you can WhatsApp me on my WhatsApp to +12694479144. Okay, guys, I would like to open to the floors if you have any questions. Any question, guys? Any question? Any question? Y'all? Or perhaps I would like to assess your understanding about this presentation though.
Dr. Nasnoor, I think there's a question in the chat box.
In the chat box. Hang on, yeah. Okay, I need to read. Oh, alright, Doctor, may I know, is there any book can we refer on this topic? Okay, send me an email, then I can show. I can share the books. It's called Foundation of Behavior Statistic from Bruce Thompson. Because the book is on PDF format, I can share it to you. Okay, yeah, I will share the slide, y'all. Any other question, guys? Oh, hang on. Okay, Doctor, could you explain what is the appropriate effect size when we conduct a quantitative research? Excellent question. How to pronounce your name? Gang Jingjin. Okay. Effect size normally you don't determine priorly. It depends on your result. Once you got perhaps the R value, the T value, the correlation, everything, from there we can like interpret the effect size, whether it's a small effect size, whether it's a moderate effect size, or is a large effect size. So that's the answer for you. But then you can estimate from the simulation what kind of effect size. Normally we try to start with 0.8 because that's where 1 minus beta, your power sample size, you can estimate the effect size. But then the best interpretation is after you get the data. Appropriate effect size, it depends though. If you are in clinical study, small effect size is still an effect, especially for you guys as a practitioner in a classroom setting, as a teacher or perhaps a lecturer. That's what we call as a practical effect size. If in clinical or in health or what, you are testing a drug, everything, that's called clinical effect size. But then if in a classroom setting, lecturing, you want to do intervention in your class, even a small effect size is still a practical effect size. Thank you, Dr. Norin. You're welcome. My pleasure, Dr. Norin. Thank you, Prof, for giving me opportunity. Thank you, my mentor, Dr. Saidun. All right. Any other else question? Because I need to prep for my another class. Thank you, y'all, my students. I hope it's, literally, I hope it is clear for you guys. If you don't don't understand, please WhatsApp me or email me, so I can give a brief or perhaps a detailed explanation. All right, guys, that's all for today. Okay, Tuan Haikal, you can take over this floor right now.
Okay. So we ending the session with our moderator, with our speaker, Dr. Nasnoor Juzaily. Thank you for Dr. Nasnoor Juzaily for topic about this topic season. So I would like to end up our discussion today. So any inquiry, you all can email to Dr. Nasnoor Juzaily and also WhatsApp for any question. So I will end the meeting. Thank you for your time. That's all. Assalamualaikum. Goodbye. Stay safe.
All right.
Dr. Nasnoor.